Black holes, the mysterious giants of the cosmos. These objects are so strange they make us rethink the very nature of gravity, space, and time. But how much of what you've heard is actually true? Let's explore and debunk 7 myths about black holes. Black holes don't roam the cosmos, actively seeking out stars and planets to devour. They are not cosmic hunters on the prowl, moving through space with a voracious appetite. They're not like cosmic sharks with an insatiable hunger, constantly on the lookout for their next meal. Instead, they remain stationary, waiting for objects to come too close. Instead, think of a black hole, more like a cosmic sinkhole in the fabric of space-time. This sinkhole is created by the immense mass of the black hole, distorting the very fabric of the universe. Imagine a bowling ball placed on a trampoline. The weight of the ball creates a dip in the trampoline's surface. That's a massive object like a star warping space-time. The greater the mass, the deeper the dip it creates. Now imagine that bowling ball is squeezed down to the size of a marble. Despite its small size, it still has the same mass. That's a black hole. It creates an incredibly steep gravitational well around it, pulling in anything that comes too close. If you roll a tennis ball representing a planet too close to the bowling ball, it might get caught in the dip and spiral inward, eventually being consumed by the black hole. But if it's far enough away, it'll just swing around and continue on its merry way, unaffected by the black hole's pull. Black holes exert a strong gravitational pull, but objects have to wander really close to get trapped. Only then do they fall into the black hole's grasp, disappearing from the observable universe. When we think of black holes, we often picture supermassive monsters sitting at the heart of galaxies. And yeah, those are definitely out there. But here's the thing, black holes come in a surprising range of sizes. Some are surprisingly petite, relatively speaking, of course. These are called stellar mass black holes, and they form when a star significantly more massive than our sun collapses under its own gravity. And astronomers have even found evidence of even smaller black holes, micro black holes, though these are still theoretical. The universe is full of surprises, and black holes are no exception. So you're cruising through space and you see a black hole up ahead. Time to panic, right? Well, hold on a second. While black holes are extreme environments, they're not instant death zones for anything that ventures near. It's all about distance. Black holes have this point of no return called the event horizon. Cross that boundary, and gravity's grip is so strong that nothing, not even light, can escape. But beyond the event horizon, it's a different story. You can actually orbit a black hole just like you orbit a star, as long as you're outside the event horizon. In fact, there are even theories that planets could exist in stable orbits around black holes. Alright, this myth is a bit tricky because it's partially true. We can't see a black hole directly. Their gravity is so strong that light itself can't escape. But here's the catch. We can see the effects of a black hole on its surroundings. It's like knowing a hurricane is there because you see trees bending and debris flying. Black holes are like cosmic engines, and the material spiraling around them forms a superheated disk called an accretion disk. This disk can glow brightly, emitting light across the electromagnetic spectrum. In 2019, the Event Horizon Telescope gave us the first ever image of a black hole's shadow. It was a monumental achievement, and a testament to our ability to observe the universe in increasingly clever ways. Black holes, actual holes in space-time. This myth is all about the name, black holes. It sounds pretty straightforward, right? Like a cosmic void, a hole punched in the fabric of space-time, but it's a bit more complicated than that. Black holes are not empty spaces. They're actually some of the densest objects in the universe. Imagine taking all the mass of a star many times larger than our sun and squeezing it down into a point. That's the core of a black hole, a singularity. Black holes warp space-time around them to an extreme degree, creating a gravitational pull so intense that nothing, not even light, can escape. So are they holes? Not in the traditional sense. They're more like extreme distortions in space-time. Black holes, cosmic statues? Think again. You might picture black holes as these cosmic statues just sitting there in space, unchanging and eternal. But the truth is, black holes are far from stationary. They are dynamic and ever-changing. Just like everything else in the universe, they're constantly on the move, influenced by the gravitational forces around them. The stars in our galaxy are all orbiting around the galactic center, creating a cosmic dance that is both beautiful and complex. And guess what resides at the center of most galaxies? A supermassive black hole. These giants are the anchors of their galaxies. When two black holes get locked in a gravitational waltz, they spiral closer and closer, eventually colliding in a cataclysmic event that sends shock waves through space-time, altering the fabric of the universe. These shock waves are called gravitational waves, and they were first detected in 2015, confirming a major prediction of Einstein's theory of general relativity. This discovery opened up a new way of observing the universe. So, black holes are far from static. They are dynamic, ever-changing entities. They're dynamic objects, moving, spinning, and even colliding in spectacular fashion, constantly reshaping the cosmos around them. Black hole =instant crushing? Not so fast. This is another one Hollywood loves to get wrong. In the movies, black holes are often depicted as cosmic vacuum cleaners, instantly sucking in and crushing anything that comes near. You fall into a black hole in a movie and it's instant pancake time, right? The character is immediately squashed into oblivion. Well, the reality is much stranger and more fascinating. Black holes are not just simple crushing machines. While a black hole's gravity is incredibly strong, it doesn't crush everything in the same way. The gravitational pull varies depending on your distance from the black hole. The strength of gravity decreases with distance. The closer you are, the stronger the pull, and vice versa. If you were to fall feet first into a black hole, the gravitational pull on your feet would be significantly stronger than the pull on your head. This difference in force is crucial. This difference in gravitational force, known as a tidal force, would stretch you out like cosmic spaghetti. It's a gradual process, not an instant one. Scientists call this process spaghettification, and it's a much more likely fate than being instantly squashed. The term might sound whimsical, but the reality is anything but. So while the end result might not be pretty, it wouldn't be instantaneous. The journey into a black hole is a complex and drawn-out process, filled with strange and fascinating phenomena. Black holes are fascinating cosmic wonders, but they're often misunderstood. These objects push the boundaries of our understanding of the universe, challenging our perceptions of gravity, space, and time. If you loved learning the truth about these mysterious objects, don't forget to like, share, and subscribe for more space adventures. Keep looking up, keep questioning, and keep exploring the wonders of the cosmos.